The night sky. Reconsider when we take a few minutes to look at our night sky. How many various things could we spectate, and how deep in the universe we dive with our eyes? From that appealing moment, we are able to see many of them, which are the lyrical objects in all of creation. Life of a star is a very interesting story that is happening in the universe. Let's see the journey of a star that starts as a gas cloud and ends as a star remnant in 7 main stages. Giant gas cloud. The birth of a star originates from a large cloud of gas, which has a temperature low enough for the synthesis of molecules. This is the first stage of a star's life, and as an example of this stage, the Orion cloud complex in the Orion system we can mention. Protostar. Then the gas particles in the molecular cloud run into each other, causing the result of producing heat energy. This results in the formation of a warm clump of molecules referred to as a protostar. This stage creation can be seen through infrared vision, as the protostars are warmer than any other materials in this giant gas cloud. There can be several protostars formed in one cloud, and that depending on the size of the molecular cloud. T-Tauri phase. When materials stop falling into the protostar and release colossal amounts of energy, this stage is called a T-Tauri star. The mean temperature of the Tauri star is not enough to support a nuclear fusion at its core. This stage will last for about 100 million years, following which it enters the most extended phase of development, the main sequence phase. Main sequence. Next in this life circle of the star, we have the main sequence phase, which is the stage in development where the core temperature reaches the point for the fusion to commence. In this process, by an exothermic reaction, the protons of hydrogen atoms are converted into atoms of helium. As a result, this reaction gives off more heat than it requires, and so the core of a main sequence star releases a massive amount of energy. Red giant. We are getting into the big part of the star now, which is the red giant. The star converts hydrogen atoms into helium over its course of the star's core, and the hydrogen fuel runs out, and the internal reaction stops. Due to this non-reactive mode of the core, a star contracts inward through gravity, providing it to expand. In this case, the star becomes a subgiant star and the red giant. They have a cooler surface in this stage than the main sequence star, and because of this, they appear red rather than yellow. As we know, the color spectrum varies according to the heat energy of an object. The fusion of heavier elements. Now, those helium molecules that converted from the hydrogen element fuse at the core as the star expands. Moreover, the energy which is created from this reaction prevents the core from collapsing. When the helium fusion ends, the core shrinks and begins fusing carbon atoms now. The procedure repeats until the iron atoms appear at the core. The iron fusion reaction absorbs energy, which causes the core to collapse in this stage. After this implosion, stars transform into a supernova, while smaller stars like the Sun contract into calling white dwarfs. Supernovae and planetary nebulae. We have come to the old age of a star now, which is most at this final stage blasted away into space. Though the core implodes into a neutron star, or as we all heard named, the singularity known as the black hole. Less massive stars don't explode like this, but their cores contract instead into a tiny, hot star known as, we said, white dwarf, while the outer material drifts away. Tinier stars don't have enough mass to burn with anything, but in the stage of the main sequence glow red. These red dwarf stars are difficult to spot, and in addition, this stage of stars may be the most common stars that can burn for trillions of years. That's how the life of a star ends, as well as all the objects in this universe would have a time for a birth, life, and then in time conversion into some kind of different material. Including we all.